Hi all. So we're going to get started again. So if you're in the lobby and want to come in, we will start immediately. Perfect. So everybody's seen domain names like .com, .net, and .org, but this year we have a new extension sponsoring NewSpace. It's called .space. It kind of fits our industry perfectly. I think if NewSpace got new .space, that would be a really awesome domain name. I don't know if it's still available. We should totally check that though. We love .space so much that we've actually chosen to live stream with .space. So for you at home, you're likely using livestream.space. And if anybody leaves today and wants to keep up with the conference, you can just go to livestream.space to check that out. You can do a lot of things with this new extension. You can create your website, build a project, write your blog, or simply follow your passion with a .space domain. So as NewSpace attendees, you get this domain discounted at $5.99 for this first year. So if you're interested, you can check that out at launch.space for more information. Right now, I'm going to introduce our next speaker. Scott is the Executive Director of ManTech International. Scott will be giving a brief update about XS-1, DARPA's experimental reusable spaceplane and booster for delivering small payloads to orbit. So let's all give a round of applause to Scott.
Thank you. It's great being here, and I really appreciate NewSpace having DARPA come in to be able to give you a couple minutes of an update as to what we're doing here with the experimental space plane. It's really interesting to see that in this program that we're dealing over at DARPA, that there's so many things that we're dealing that's very much in line with what NewSpace is doing. We're trying to tie in entrepreneurship, novel innovation, technological innovations, and these public-private partnerships are all kind of what we're looking at doing over the course of the next 4 years. And it's hard not to get excited when you take a look at what's happened over the course of the last year when it comes to just reusable space or space launch in general, with SpaceX and Blue Origin making their landings, and then some of the new startup companies being able to drive down the cost of their expendable vehicles. And we're in that same vein. What we're trying to do is combine the best of reusability and expendability in order to drive down the cost of space and the time to actually get to space by an order of magnitude. If you take a look at the history from a civil and military point of view, we've been trying to get into the spaceplane world for probably about 40 plus years. We had some initial concepts during World War II, but our biggest success, I believe, was during the X-15 period, where we're able to successfully show that we could have a reusable rocket that actually acts out like a plane. From the 70s and 80s, we started working on the space shuttle, National Aerospace Plane, which was a huge jump towards this idea of a single stage to orbit, and then backed it off a little bit with our X vehicles of 33, 34, 37, and 40. All these X vehicles in this series, we're really looking at trying to figure out those technologies necessary, the core technologies necessary in order for us to be able to have this idea of reusability. And then over the course of the last 10 years, you still have NASA and the Air Force kind of working on those core technologies, but one of the things that is very obvious to see is that we still haven't gotten there yet. And that kind of comes down to this idea of why not? So what we do is we kind of break it down into two areas. What has changed? Basically, we believe right now that the technical readiness level of the core technologies are at a point where we could actually make a marked improvement in the way we do our operations, and then how we actually at DARPA were able to reduce the specificity of the requirements so that we can get something done in a very short amount of time. When you take a look at the technical readiness levels of our initial programs, when you took a look at the STS, NASP, and the X-33, we're way down there in about the 2 or 3 level, which would have taken a huge amount of time and focus over the course of maybe several political partnerships in order to actually make that happen. And then when you take a look at some of the specified requirements that were actually there, such as single stage to orbit, or air-breathing scramjets, or very heavy lift, or even putting humans into space, all that did really was increase the level of effort necessary in order to prove some of these core concepts. When you take a look at the technologies that are available right now, this is where we think we're at that point. What we're trying to do is drive towards aircraft-like operations, and what you see with our civilian aircraft. And that is our mindset. That is what we're actually going forward to say, if all of our priorities that are out there, that is number one. We also know that our material, what we're using for our composites, can actually be used now in a much more efficient and affordable way to drive down the weights as well as the cost. And then we have the ability to use our modeling and simulations far to the left of a normal program, so that you could iterate several times prior to even putting a pen to paper, or start bending metal, or laying down your first amount of fiberglass for the very first time. And then you take a look at what the requirements are. So we talked about the old over-specific requirement, but from DARPA's perspective, it's a little bit easier. I mean, quite honestly, what we're looking at, and from a simple perspective, is having a reusable first stage, an expendable upper stage, and we're designing this thing such that we could put about 3,000 pounds into orbit. The hard part, though, is driving down that cost, not a price, but a cost down to $5 million per flight over some number of flights. We're going to demonstrate this by putting 900 pounds into orbit one time to say, hey, this is how we can prove that we're successful, at least from launching something into orbit. And then the key of this is actually trying to make that reusable booster fly 10 times in 10 days. We think if we're able to do that, you're going to be able to have the foundation necessary in order for you to go into a commercial business and start flying this thing at a high rate and being able to drive down the costs. The three pictures that you see here are the preliminary designs from phase one, where we had Boeing, Maston, and Northrop Grumman come in and say, we have basic designs that we think are going to be able to make this thing happen. And one of the cool things about DARPA is that we were not overly specific. We didn't say it had to be a vertical takeoff, horizontal landing. We opened it up to anything that was absolutely possible, and then we down selected three individuals who we thought had the best chance of getting something done during phase one to see what actually needed to happen. As I said beforehand, designing for aircraft-like operations is our number one goal. So if anything else is to stay static, it's going to be this. If weights start climbing, we're going to let the payload decrease just a little bit, because our core idea is, how can we ensure that we can have this thing fly on a continual basis? So if you're designing for aircraft-like operations, you're also designing for sustainability, maintainability, suitability, reliability, availability. All these things are set at the very beginning, and then you move forward there afterwards. If you supplement that with this whole idea of clean pad operations, where you're able to drive down the costs of your infrastructure to something that is essential but not superfluous, now you're able to get rid of some of those extra costs that would be non-recurring. And if you start tying in autonomy, and you start tying in this accessibility to the aircraft, you could start driving down the number of people, the standing army necessary in order to run this over the course of several years. And in doing these three different types of thrusts, if you will, and how we're doing our operations, we feel that you're going to be able to keep those non-recurring costs to an absolute minimum, and then you're going to be able to drive up or shorten the amount of time necessary in order to get these things to fly. So where are we right now within the XS-1 program? We just spent the last 2 years and $40 million working on phase one, which was really giving us a preliminary design of different concepts, and we started focusing on ground demonstrations, tech demonstrations, and critical technologies that we think are going to be core for aircraft-like operability. Additive manufacturing with propulsion is one of the key ones that we're moving forward, even once we go in towards phase 2 and 3, just as extra types of ways of reducing the cost. We're at the end, just about at the end of phase one. We're going to start going into phase 2 and 3 here, and we're doing this with another transaction authority, which for us is quite unique. We're going in there with the idea that we're going to want to do this with a public-private partnership, such that at the end, we're going to be able to deliver a capability to the commercial sector. And then as they start flying this thing to their own business models, we as the Department of Defense are going to be able to buy back those services in order to do whatever the needs are of the requirements that we actually pull out there. Let's go back here for a second. And what we're going to do, this is in the course of the next 3 years. So we have about 1 year for final design. We're going to have about 18 months of fabrication and getting this thing ready to fly. And then by the end of 2019, beginning of 2020 time period is when we're actually going into our flight test phase, which should last about 9 to 12 months. So we've talked about this a couple other times, and it's very hard to set the standard of, well, if you have this reusable aircraft or spacecraft and you expect them flying a lot, is there going to be a demand for that? And so we've done several independent studies in order to try and figure out whether or not there is going to be that demand. But everything that you're going to study is really going to be wrong. It's just how far off the mark you're going to be. In this one particular study, we had SpaceWorks actually work for us. And they took a look at, of the market, what is going to be the max achievable that's actually out there. And when you take a look at the numbers on the left-hand side, you're seeing numbers in the thousands, right? And weights and masses over there in the millions of pounds. This is the max possible that's out there. We know that that's not going to actually happen. But if you start taking a look at 5% of that, possibly 10% of that, and you start bringing down the numbers to what is realistic, which is not just into the commercial, into communications, but also ISR, and all these novel ideas of capabilities that are going to be out there, you start getting into something in about the 10, 15, possibly 20 flights annually. Well, we built this program such that if you have, say, 5 to 15-ish sorties annually, you're able to close a business case and actually make this thing a viable system. If you're able to fly once a month, now that standing army and all the excess money that you put into the non-recurring costs can be amortized over the course of its life cycle. 10 flights in 10 days is huge. All right? If we're able to do this, we're going to be able to change the way we do business. Up until now, we've always been on this whole idea of launch on a schedule. You take 18 to 24 months from the time that you actually want something, you start working with a partner, you get something and you launch it into space. If we're able to do something like 10 flights in 10 days, we could go more toward launch on demand type way of doing business. So by doing this, now the Air Force and any of the military entities that are out there can start thinking about different architectures like disaggregation or resiliency, and how can they start using affordable launch costs that can be launched on a moment's notice to help augment what they're doing from a defensive posture. From a commercial idea, it works out quite well as well. Instead of sending one single Delta Heavy with 500 or 500-pound satellites that's going to be able to put a constellation up there for $500 million, maybe you don't want to have all that risk in one launch. You reduce it to single launches of, say, 10. You throw everything up in a single plane, and now you're able to distribute your risk and get these things up there as quickly as possible. And in doing so, what you're actually able to do now is start thinking about this whole idea of making time to space down to an order of magnitude, and you're going to get costs down by an order of magnitude. Let me take a look at one last thing here. All right. So the whole idea of what XS-1 wants to do is change the way we do business right now. We have the current way of doing business. We have people who are striving to bring reusability to the table. What we want to do is take that a step further and start seeing how far can you drive these things down. And if you can get costs of $5 million per flight, and if you're able to go from several months of time delay to a couple of days to get an encapsulated payload in orbit, then we've been successful. And then by doing this and providing it to the industry or to the commercial markets and let them take this and move forward and build their own business cases upon it, we as a military and as the Department of Defense can then use that where we think is necessary in order to develop these new architectures. So on that, I believe my 15 minutes is up. I'll be back here after the next break for any questions that happen to be there. One question.
Is this working? Yeah, DARPA has had a number of these projects with rockets, and the most recent one was Alassa, which was canceled after spending about $46 million, and they discovered that the fuel exploded on its own. Why is this not another one of these DARPA projects that's overly ambitious and underfunded and will end up producing a lot of cool hardware?
All right, so the question is, how is this different than, say, Alassa or some of the other programs, right?
Yeah.
Well, one of the biggest reasons is because of where we see the technical readiness level. We're not using a monopropellant. We're not using systems that are so novel that we just don't know whether or not they're going to be able to make it. What's challenging for us is the actual integration of all these different concepts that have been done in parts and pieces, putting it together in a system and allowing that system provide us a new capability.
Well, yeah, I mean, it's just 10 times in 10 days. Why not aim a little bit lower and say, like, once a week,
Because then it wouldn't necessarily be DARPA hard. What it comes down to is if you're able to fly 10 times in 10 days, what you're really doing is you're taking off the table this whole idea that reusability is something that's too difficult to do, that you can't just gas and go with a system. And that's what we're trying to do. Now, quite honestly, if we hit 8 times in 8 days, 8 times in 10 days, we still will have met our mark of showing that a gas-and-go concept for a spacecraft is actually going to help us as we move forward into the future.
Okay, fair enough.
Okay. All right, thank you very much.